Letter G. G comes next. Dilute hydrochloric acid placed into a solution of potassium sulfite, and we're being asked to consider the spectator ions. Well, let's begin. Hydrochloric acid, HCl, with potassium sulfite, K is a +1. Sulfite is our polyatomic ion, SO3, and it carries a -2. So we get HCl plus K2SO3. In the double replacement pattern, H goes to SO3, but based on charge, we would get H2SO3, and potassium goes to chloride. Based on charge, we get KCl. Let's take a moment and balance. 2 KCl's, 2 HCl's, and we're good. Now, the double replacement is now followed by a decomposition. We once talked about H2CO3, carbonic acid, being a weak acid. Once it forms, it decomposes. Sulfurous acid will do the same thing. So H2SO3, once it forms, it decomposes, and what we end up having is sulfur dioxide and water. So this is one of those patterns that's a double replacement followed by the decomposition, where the driving force is the sulfur dioxide gas. So considering the ionic equation, we have a strong acid, so we'll dissociate 2H plus and 2Cl negative. The strong electrolyte, potassium ions, and the sulfate ions will dissociate. The acid is no longer there, but in its place is molecular water and the sulfur dioxide gas leave together. They're both molecules. Potassium chloride is an ionic salt. It will dissociate. The spectator ions we should eliminate include the potassium and the chloride. This particular the particular net ionic equation has 2 units of hydrogen ion plus SO3 minus 2 forming water and sulfur dioxide. The spectator ions we're showing are the potassium ion and the chloride ions.